Hello, welcome to my presentation. This is the TPG3700 assessment for project presentation. In this presentation, I will take you through how I completed my project. My project was completed in partial fulfillment of the module TPG3700 of the Advanced Diploma in Civil Engineering Technology with the University of South Africa, the College of Science, Engineering and Technology under the Department of Civil Engineering. My name is Vuyo Pandle, student number 65380495. Again, I welcome you. In completing this presentation, I had to present it in this format of the PowerPoint. I could not display my PowerPoint to the full screen because it freezes my computer while I'm recording. Anyway, in continuing with the presentation, in completing my project, I decided to select the road D3727 for upgrade. This road is a road in Limpopo in the Vembe district in Elim. This road is a road located in a very rural area that connects two villages together. Namely, the villages are Amashamba and Mokonde. The road is under the Roads Agency Limpopo. The road was earmarked for upgrade, and the reason for this was because the road was a very important road that connects the two villages together and connects the two villages with the main road that leads to town. So it was very important that this road becomes upgraded so that people can be able to move easily between villages and to town, and that people can access services and be able to go to town for to satisfy their other needs. In completing this project, I elected to use the technical recommendations for highways part 4 or TRH4 as my standard guideline and the geometric software Autodesk Civil 3D student version. Selection of analysis period and structural design period. Now, when you're designing a road, it is very important that you decide on the analysis period and the structural design period. These two elements will help you in deciding on the number of years you want your road to last for, and the kind of road the kind of construction that you're going to incorporate when constructing this road. Sometimes you could decide that you'll use fairly cheap material so that during maintenance, the road can require a lot more maintenance, or sometimes you decide as a designer that you'll use strong and relatively expensive material so that your road can require moderate or just not so much of maintenance. Now, for the analysis period, as the designer, I selected a 20-year period. The reason behind this is because I expect that the village will develop, because the village currently is very rural, but it has a lot of potential for development, and such infrastructure will help it to develop. So I expect a lot of development, and as a result of this, I expect that the traffic situation is expected to change as the years go by. So I elected to use a shorter period used over the recommended, a shorter analysis period used over the recommended 30 years. And then for the structural design period, a structural design period of 20 years is selected. I selected to use this structural design period because it is the same as the analysis period. The road will be structurally adequate during these 20 years and will require at least 3 surfacings during this time. The design traffic. The cumulative equivalent traffic in this case will be equal to the total equivalent traffic loading, which is 1 times 10 to the power of 6 E80 per lane per day, which is ES3. Classification of pavement and traffic for structural design will be ES3. Pavement design bearing capacity is 3M 8 kilonewtons per axles per lane. And then the projection of traffic loading over the structural design period. Well, this in compilation of this part, the road will be open after 2 years of the determination of the Excel data. Then we found that the growth factor of traffic in this case was found to be 1,042. So the AADE was found to be 226,450 vehicles per year. Further calculations and details behind this are included in the report. Materials. It was found that a quarry was identified within the village in the road area from which G4 materials can be sourced. A lot of G4 materials was available, and we found that it can be sourced from this quarry and be used in during construction of the road. Of course, all of these can be possible only with the permission from the local chief and the client. And then the pavement structure is as follows. The subgrade is G7 material, and then rip and recompacted, and then the subbase is G4 material. The base course is G5 material, and a 30 millimeter surfacing asphalt course will then be provided for. For the geometric software program, which is in this case Autodesk Civil 3D student version, this is the steps that I followed in designing my road. I imported the survey points. This is very important because you cannot design a road without importing survey points. And then after importing survey points, I created my existing surface on the ground. I created my alignment, and then I created the proposed profile. In creating the alignment, you create the horizontal alignment, and then you can also create the vertical alignment. I created the proposed profile, and then I modified the profile. There were a lot of cuts and fills. A lot more information about the cuts and fills are in the report. There's an extra A, which shows my cuts and fills table. And then I modified the table to make provisions for the cut and fills. And then I created the finished ground surfaces. And then I printed out all section views. All of these section views are also attached in the report. Thank you very much for joining my presentation. I hope you have enjoyed it, and I hope it was impactful and informational. Thank you again.